Today, only for you, we're going to use the trapezoidal rule for approximating area under the curve, which is essentially the definite integral. So, quick reminder, the area of a trapezoid is the height times the base 1 plus base 2 divided by 2. So height times the average of the bases. So what this is often represented as TRAP, just as trapezoidal, right? So if I have a curve, we did it where we had it as a rectangular approximation. But say I'm going from this point to this point, and let's just do two subintervals. So I have this point, and here that I'm trying to find the area of. Right, so rectangular approximation was okay, right? There's our right approximation. Here is our left approximation, and it was okay, but it's not really that great. So what mathematicians did is they said, well, hey, look, there's a better shape, and it is a trapezoid. If I take a trapezoid, right, but this is essentially a trapezoid turned on its side, where I have the height, h1, h2, but h1 and h2 will be the same since I'm taking the same divisions with these things. And then I have my base here. This would be like base 1, base 2, base 3 if you want to call it that. So essentially I have my trapezoid where the bases, base 2, base 1, and height, right? The bases are the y values of my function. So this is going to give a much, much better approximation of the area under the curve. And then we'll get more accurate eventually. For a concave up, it's going to be an overestimate. Concave down, it'll be an underestimate. Right? So if I have a concave down graph, whoop, that's not where I want it to be. Concave down. And I'm going there, there, and there. So shoo, ba-doo, ba-doo. And I draw my trapezoid. It is barely under that curve, so this would be an under approximation for my trapezoidal approximation of the area. So let's just get into it. There's really not a whole ton to mess with. It's just making sure that you know that trapezoid formula as you go. The nice thing here, though, too, is because I'm going to pick equal subintervals, the height are all going to be the same. So I can essentially do height over 2 times base 1 plus base 2, whoops, plus, and then go on to your next figure. The other cool thing, which we'll see in just a minute. So let's go ahead and mess with this one and see what we get out. So use the trapezoidal rule to approximate the value of the definite integral for the given value of n. All that this given value of n is how many subintervals they want you to take. So I'm going from 0 to 2 for x squared. So if I want to think about my graph, I have something like this. So 0, here's 1, here's 2, and if I want to have 4 equal subintervals, that means I'd have 0, 1/2, 1, 3/2, and 2. So I have 1, 2, 3, and 4 equal intervals. I have the trapezoids going here, so this will be an over approximation. So let's see, my first trapezoid there, my first base length is 0, and then my other base length is 1/2. Or sorry, is 1/2 squared, right? Because my function is x squared that I'm trying to find the area under the curve of. So the area would be the height divided by 2. So I'm going to take my heights, they're all 1/2, so divided by 2, that would really be 1/4, right? And then times my base 1 plus base 2, so 0 plus 1/2, plus the next rectangle, or sorry, next trapezoid would be that one. And my base 1 plus base 2 there would be 1/2 plus 1. My next one would be right here. So I would have plus 1 plus 3/2, plus the next one would be right here. So plus 3/2 plus 2. And if you notice, right, this is how all of my trapezoids are split up, so I have 4 trapezoids there. But the other thing that's kind of cool is, right, this 1/2 and this 1 and this 3/2, I'm essentially adding those and doubling them. So we can take that as we go. The only things that are not doubled are my endpoints out here, my 0 and my 2. Those heights are the only ones that are not doubled. And I'm sorry, I wrote this all wrong. This should be f of 0, f of 1/2. Ah, poop! Poopity doop, doopity doop, poopity joopity doo. Back in the song. F of 0 plus f of 1/2. F of 1/2 plus f of 1 plus f of 1 plus f of 3/2. F of 3/2 plus f of 2. Okay, my bad, because it's the y values of all these things. So trapezoid, 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 trapezoid. So to simplify this, this will be 1/4. F of 0 is 0, and then it would be 2 times f of 1/2, which is 1/4, plus 2 times f of 1, which is 1, plus 2 times f of 3/2, which is 9/4, plus f of 2, which would be 4. Type that all in your calculator. Let's see, how fast can we go? Did you beat me? 2.75. You probably did. Units squared. All right, so that would be my approximation of that area under that curve. So we don't need to do this every time as far as drawing the picture out, but you do need to think about what your interval looks like, just like we did for the rectangular approximation methods. Okay, moving on. So this is an instance, I don't necessarily want to draw this out. This graph does look like shoo-ba-doo, shoo-ba-doo, but I just don't feel like drawing it out. But if my n is 4, I'm splitting up 3 minus 2 over 4, so each interval will be 1/4, and my function here is 2 over x squared. So for my area, I have 1/4 divided by 2, right? That's my height. My heights are all 1/4. So now I have times, I'm going to have to go by 1/4, so f of 2 plus 2 f of 2 would be 8 over 4, so 9/4, plus 2 f of 10/4, which is 5/2, plus 2 f of 11/4, plus f of 3. All right, so I kind of simplified that already. So here's one trapezoid, here's two trapezoids, 3 and 4, right? Because remember, I'm doubling those because I'm going to repeat the same thing over again. So let's see what we can do. 2 divided by x squared. So this is 1/8 times y1 of 2 plus y1 of I'm way slow at typing this in. Hopefully I don't get it wrong. If you get something different, let me know, and I can come back and edit this video for yo. For yo! Come on, Joe. Okay, so I get 0.3352 units squared. Let's see if I do that as a fraction. It says no, I will not do that as a fraction. Okay, and that's it. That's really all there is to this. So here, my heights are all going to be 1/2, because if I do the difference between the interval, right, from 3 to 0, and if I want to divide that up into 6 equal intervals, each interval will be 1/2. So there's my height. So 1/2 divided by 2 times f of 0 plus 2f of 1/2 plus 2f of 1 plus 2f of 3/2 plus 2f of 2 plus 2f of 5/2 plus f of 3. All right, so again, thinking about this, if I had to have 6 trapezoids, I have 1, 2, 3, 4, 5, and 6, because I'm doubling those bases as I go out, just like we talked about in this first one up here. Okay. So then it's just a matter of typing all this in. So let's see what we can do. And to make my life a little bit easier, I'm going to type it in my y equals. That's what I did on the last one too. So let me show you what my home screen looked like. Right, so on this one up here, right, I had it stored into y1 so that when I did all of those calculations, it would do the y value for me. I didn't have to do any calculations beyond just typing in y1 of whatever. Right, and we do that by doing y1 equals, what do we need to equal in this case? X square root x squared plus 1. So y equals x square root x squared plus 1. Right, so now when I do my calculations, I'm going to do it on my main screen. So let me do that, and then I'll show you what my calculator looks like. Add that to your compilation, Jonathan. J-Lo! Kids these days. I used to say that when I was a young teacher, and it was funny because I was a kid too, but I'm no longer a kid. I still act like one though. That's a bonus. Okay, so that's what my calculator looks like, right? So I have 1/4 of all of that stuff that we just entered. Oh, except I forgot my 2 right there. Oops. I need to hit second delete and insert a 2. Oh my goodness. What are you doing? Why is that a 3 and not a 5? Oh my goodness. What are you doing? That's just all wrong. 3 halves. 2, 2. That should be 5 halves. Oh no. Oh no. He did it again. Oh my gosh. Oh, I must have gotten mixed up or something. I don't know. Okay, let's verify. That first one is wrong. Oh, show. Okay, 1/4. y1 of 0, 2y1 of 1/2, 2y1 of 1, 2y1 of 3 halves, 2y1 of 2, 2y1 of 5 halves, 2y1 of 3, but not 2, just 1. Okay, there we go, 10.312. Yeah, 10.312. All right, and that's really it. You guys have 1 through 10 as your homework tonight. I think I just did 2 of them, 2 of the evens. So I will not put 2 of those evens that I did. I did number 4 and number 10 for you. Happy birthday, congratulations. Well, I kind of did number 10. 10 is just, I added some more to it, but you can count doing it as 10. It's just extra practice. All right, other than that, let me know what questions you have, and I will talk to you all soon. Bye.